So again, at the end of the day, Darren Ghost will send email when these recordings are available. So I want to cover Sysctl quickly and then get back into the virtual memory and the memory module and the memory map that I was introducing you to in the prior demo. So again, don't let me assume too much about both of you. Ask questions if there's something that I'm skipping over too quickly. So primarily, I'm trying to introduce people to the Sysctl command and how it works and uses it. And we will be dealing with a variety of Sysctl parameters this week. In particular, the important ones will be the VM group and these dirty ratio, dirty background ratio, swappiness, VFS cache pressure, dirty expire centiseconds, stuff like that. So there's about 30 to 40 Sysctl parameters for us to play with this week. One of the options here, SAR, has the ability to track the size of tables, the number of processes, number of open files, things of that sort. And again, in lab, the key one here is the kernel parameter threads-max. This is the maximum number of threads the system can handle. When the threads max is reached, forks will fail. Now, there are a couple things to talk about here. I'll come back to them. But one of the key things here is as the memories get bigger and bigger, threads-max gets big. And it's easy for a user to do a service denial attack and storm the system with threads, creating all kinds of problems. And that's what I want you to see. There'll be a Mystery 1 script you run that basically bombs the system with forks. And the child that it spawns just does a sleep, so there will be no load, just the fork itself. Also, because you're spawning so many threads, when they are done, they will sleep for like 60 seconds and then they will go away with an exit. But because there are so many, you will see zombies for a while. So zombie is a process that is dead, but is still in the process table. And there are different types of zombies. In this case, the zombie will go away once the kernel is able to clean up all the zombies. But if I'm creating 100,000 zombies, they're going to hang around for a little bit. Okay? So there's threads-max, and there's a couple other that we need to talk about. So I'm trying to introduce resolving system problems by modifying Sysctl, and also to find out where to find information on Sysctl parameters. So Sysctl is a Linux command, kind of like systune and IRIX. You don't actually need Sysctl. It's a user-friendly command line interface, but some sites might just go straight into proc sys. In fact, I still get cases where Sysctl is out of sync with the kernel, and Sysctl might say this parameter doesn't exist because that kernel no longer has that particular proc sys entry point available anymore. In 99% of the cases, no boot is required, but there are a couple of Sysctl parameters that I would reboot, particularly in huge pages. Requires root to make any changes. During my inventory, and that system info gather is running a Sysctl-A to get what your current settings are. As soon as I've got a system that is going into production, and the first day, maybe I've installed the system, configured it, and then I gave a week of access just to pound on the system and see what kind of problems it creates, and then cleaned up those problems. And now I'm into a week of production mode. I would want to grab a Sysctl-A, or actually, I'm sorry, a system info gather with 5 V's on it to get a snapshot of what my system looks like before things start deteriorating. That's my reference or my baseline. The newer system info gather was intended so that after a benchmark, I could snapshot my system and reconfigure it a year later to the same way that the benchmark was done. So Sysctl-A is in the inventory script. Also, I am grabbing sysctl.conf so that I can see what things have been changed by the site. So during my inventory, I always like to check sysctl.conf first to see if they've done anything. And in particular, I am advising dirty ratio, dirty background ratio, swappiness to be adjusted. We'll talk about those. So lots of times one of these parameters, they might have put in the parameter 5 years ago and are still carrying the parameter forward, but it was a workaround back then that is no longer needed. When we ship a kernel, the sysctl parameters are basically shipped as best middle of the road compromise with the safest defaults. But again, the kernel and the setting of the memory management parameters does not deal with large memory kernels. I'm going to go to a whiteboard here. So you should be able to see my whiteboard. So in the older days, we would have the memory size. Sorry, let me go to a smaller pen here. Over here, and then
I'm not seeing the whiteboard.
Down here, for example, threads-max. And on Linux, it's a linear function. On IRIX and Unicos, it would roll off after a while. So it'd say there's no point in growing this after we hit a certain memory threshold size. So the fact that Linux does this, IRIX and Unicos, for example, did something like this, means that on these huge UV memory systems, numbers like threads-max can just get way too big, and they should be dropped back down. So threads-max, dirty ratio, dirty background ratio are a couple of sysctl parameter examples that really need to be adjusted on large memory systems. Any questions? That's not a battle I've been willing to fight in terms of a bug or filing a feature request. But they really should be scaling things off a little bit more and not doing everything just based upon memory. So, sometimes you might end up commenting things out to get back to the default, or having had the sysctl-A in your inventory, then you know what the default was. But I would have to do a reboot to get some of these things back to the default, the vanilla. So here's just a sysctl-A. It gets very noisy on a large CPU system. The system info gather that I have now does not print out. It filters out and gets rid of a lot of the per CPU sysctl parameters for large CPU counts. So you need to go to 5 Vs to be able to get the full sysctl for every CPU. But again, the newer verbosity levels were to handle large CPU count type systems where you get 4096 CPUs and a ton of data on them. It just got too verbose. And I need to show you a little bit, but when I'm in System Info Gather, I can now search on a header. If I'm in System Info Gather, let me do it here. I can do search on like 1, 2, 3, 4 Vs and a space, and then that'll get me to the next command output. Let me demonstrate that later. So the headers in the System Info Gather make it easier to get to the next command output if you're in a verbose output. Also, there is a man page now for System Info Gather. So this stuff is in System Info Gather. I'm seeing one of interest to me here. Core uses PID. If I have my limits set large so that I can get core files, and I do it by PID, and I go 4096 threads wide, I'm going to have 4096 core dumps storming my system. And a core dump will impact performance when you've got that many going. Your file system buffer cache will be pounded on by the core files being generated. So if that's a non-zero, that could, if I do get a core dump occurring, that core dump storm could stall out my system for a half hour. So using sysctl-W to write. So this one, I'm just changing one called restrict to own. That is for XFS. When it's a 0, that says I can own my files away from me. So if it's a 0, I could be TNG01 and I could own them to guest, and then guest gets the bill. If own is set to a 1, then only root can change the ownership of files away from a user. The other one I have here that we're going to be doing in lab is threads-max. That is the maximum size of the process table. And max procs before a fork failure. And in lab, you're going to run a mystery 1 script to actually push it to the limit. And then see fork failures, change this value, and then see the process storm value change. And at what point do the forks actually start failing? The other one here, you do have parameters that have multiple fields to them, so you do have to delimit them with quotes. Otherwise, the command line, the shell parser won't pick that up. Now, the W is only on live systems. Otherwise, I might put it into Sysctl conf, and sometimes I'm doing this. So I might vi etc sysctl.conf, and then, for example, add kernel threads-max, and I think there's a space in there, and then let's just say 16.384, good enough. And then after that, I'm going to do a sysctl-p, which will play back and set values from sysctl.conf. So different ways of handling it. If I'm just testing but don't want it to persist, I'll use a W. If I want it to persist, I'll add it into sysctl.conf and then use sysctl-p to set the values based upon sysctl.conf. Any questions? This is the best site in my mind for documentation. I'm going to share my desktop. Linux Insight, I'm going into Proxys Hierarchy. So this is a wiki, but it's still basically descriptions that are coming out of the code itself. I've not gone in and started adding my own comments, for example. These are the different groups in Proxys. Kernel, for example. Let's click on that one. And now I've got all the kernel group parameters of interest to me. There's that core uses PID. Let's see. Message limits for interprocess communication. Here's that NMI watchdog. That thing is watching a CPU. If it isn't responding, it will NMI that CPU. We are turning that off by default in our elilo.conf. Let's see. PID max is going to be relevant to us. In fact, I got a lot of sites. When you're on a 4096 CPU system, a lot of your PIDs are going to get used up by kernel threads. And then sites were complaining about PIDs were changing, rolling over back to a low number real quickly. And you're going to hit PID max in your labs before you hit threads-max. So PID max is directly relevant to the lab that we're going to be doing here. Print K controls, semaphore controls. This one I want to talk about later in the week. Get compat yield. I do recommend setting that to a 1. Semaphore limits and shared memory limits. So for example, SHMEM all, let's just click on that one. System-wide limit, total number of pages that shared memory can take. And by default, it's half your memory on the system, but we've actually upped it to basically make it unlimited. This makes it easy for me to attack your system. Now we'll come back to that later. So the SHMEMs are very relevant. SysRQ we often are setting to a 1. And here's the one that I care about, threads-max. Oh, there's a new one here. Unknown NMI panic. That's new. I just want to check it. Because I was getting NMI. Non-zero unknown NMI is trapped and then a panic occurs. I'm getting something new that I want to try to trip over this week. Grep dazed in var log messages. Let me try it with a -I. No, not seeing any there right now. Let me see. Don't see any right now. Last week I was getting what's called dazed and confused lost NMI messages. I'll dig up that. I may even try to trip it later. So this is relevant to me because I was hitting this last week. Now the panic I had this morning was not an NMI one, but I might turn that on to try to catch a little bit more. So the NMI watchdog is also turned off when this value is set to non-zero. So for me, that is a relevant option for me to handle, but again, it would result in a panic, which I would not do on a production system. But I'm in pre-production and I want to start catching some of these NMI problems that I was seeing. All non-maskable interrupt handling was rewritten. Notice on our systems here, I am in a 3.0 kernel. And NMI was rewritten, and this is where all the patches that are going into a PTF kernel, there's probably about 8 to 10 of them that have to do with NMI. Let me do a PS-E into more. And I do not have an NMI watchdog set here. There would be an NMI watchdog process here. I'm just going to try something here, sysctl-w kernel dot NMI_watchdog equals 1. I don't know if a reboot's required, I'm just checking. And yeah, I don't see anything, but on the next reboot, I should be able to get one. But again, if I grep NMI in proc command line, since I booted, and again, that's a typo there, but this is the one that has it off. So that's an example of one that even though I tried it, a reboot would be required for that one to work. Okay, but I want to run with NMI watchdog off because that's the way we're going to ship it. And that's the way they're testing. Any questions? Now let me go back. I was just looking at some different sysctl parameters, and that one was one new that I'd seen. This is the one that is going to be in the lab. Maximum number of running threads system-wide. And a process is 1 or more threads. So if I had a multi-threaded application, OpenMP, that went 4096 threads wide, that would get counted as 4096 of this threads-max. We okay? Any questions? I think I want to go back. For me, I want to try this one. If I do have something happen, I am in debug mode and I want to have that one done here. So I'm going to do a VI. First of all, let me do a sysctl-a grep for NMI. So I know my watchdog is a 1, but we don't really see it. Panic on unrecovered NMI is a 0. Let me edit my ITSI sysctl.conf. By the way, I am looking at the sysctl.conf, and I do see that it is running this stuff here was added by me. I've already made some changes here. SGI adds in this stuff. So these are increasing network socket sizes, for example. But I've added in 3, and now I'm actually adding in a 4th one here. So sysctl-p, oops, let's see, did I spell it right and everything? Panic on unrecovered NMI. Oh, I know what I did wrong. We okay? You following me? I do like bugs like this. So now let me try playing it back. And it played it back cleanly. These are the things that it reset, and I now have that thing set to a 1. I will cover these later in the week. And I'm assuming, Carlos, that yours is a clone of Floyd 3, that yours is in the same situation. But you don't need to do this. I'm just doing this because Floyd 3 is going to be the system that I pound on for demos. Any questions? So I've gone off to this Linux Insight website, which is a good place to go for some of the documentation on the different sysctl parameters. I wonder what this one is like. So this one's, we'll talk about proc VM stat later today too. Not a whole lot of description though. Okay, back to the workbook. Any questions? We okay? So I was just trying to apply the Linux Insight website, looked up something, saw something new directly of interest to me because I'm dealing with some NMI. It's called dazed and confused messages coming out on dmessage. I'm going to try to create some this week. And this way, I'm wondering if it will panic when it loses an NMI. And I'll deal with that later in the week. Also, when you have the kernel source loaded, user source Linux documentation, there's a sysctl file. In documentation file systems, proc.txt describes /proc. Also XFS for XFS settings. And network stuff, there's an IP sysctl.txt. Again, we do have some stuff in Linux configuration guide, docs.sgi.com. XVM has some sysctl parameters, and CXFS also documented just in those manuals. So, if there aren't any questions, moving on. The lab is setting you up to play with the process table, also referred to as the task table. It is a table of all existing processes and threads that are managed by the kernel. It's in the slab. It's in the slab, or the kernel heap. The threads-max controls the maximum number of processes on the system, but there's also, on a per-user basis, the limit and ulimit command, and in itsysecuritylimits.conf. I do advise sites to configure that and drop down my thread limit on a per login session. And there's documentation on that. So every time a new process is created with either a fork or a clone, it's assigned a slot in the process table, or internally they call it the task table, and it gives it a unique PID. PS-EL prints out the contents of the task table. I can also go into crash and print out the task table. Threads created with clone will show up with a PS-MT, capital T for threads. And when I'm in top, I need a capital H to see threads. So by default, PS and top are not showing me threads, just processes. And there is a proc PID task, TID, and then the individual information for that thread. So under proc PID, the proc PID directory is all threads added together. And then we have a task subdirectory with a directory under it for every thread that it has. There will be at least one thread for every process. If I'm OpenMP, or pthreads, there will be more than one thread ID visible there. We okay? Any questions? Are you still there? I see Carlos not seeing my desktop. Is anybody there?
Yeah, still here.
Okay. My page.
You've only got the slide up, haven't you?
Yeah.
Yeah.
I'm just double checking. My paging isn't working right now for some reason. I've locked up again. Shoot. That's not the last page of the workbook. Huh. Let me see if I can open it again. My paging is frozen up. I'm not able to advance to the next page. Okay. Okay, I've got some sort of problem going on here. Oh. Yeah, I'm still not able to advance the page. Okay. Carlos, are you still there? I've gone back to my desktop. Carlos, are you there? Can you see my desktop now? I don't know. Carlos, are you there?
Here.
Okay. I'm going to do a quick demo, and then I'm going to have to reboot my WebEx session or something. I don't know why my page advance isn't working. But what I wanted to show you here now, Sysctl-A. Oops. Oh, I know what happened. Hang on. Okay, I had this happen before. My USB is working its way out of the USB socket. That may be my problem. So let me do this first. Sysctl-A, grep for threads. Look at that. I am allowed 4 million threads on this system. That is extremely large count. SAR-V, no, SAR-Q, and my process table size is 572, but I can go up to 4 million before I start having forks fail. Now that allows a process storm to occur. That is a service denial attack opportunity for me to attack the system intentionally or unintentionally. And let me do a ulimit-A. And threads, where is it here? Maximum user processes. I got 2 million. A single session, I can storm the system with 2 million forks before it fails. That is half of this 4 million here. So with 2 login windows, I can attack the system and nobody would be able to use it because all the process table entries are being consumed. I don't know how much IRIX background you have, but on IRIX, the ulimit command was 1/10 of the total, not half of the total. So I might do an ITSI security limits.conf, and I do advise sites to do this. And then I can say, where is it here? nproc. I'm not going to do it, but I could put in an nproc. Let me just do it as a comment here. Say for everybody, my hard nproc. And I had 2 million before. Let me just go to 50,000, which seems to me, oops, still a lot of threads for something to spawn, right? And then I'm going to go to a soft. And maybe go, well, I could have 4,000 CPUs. Maybe I'll just make it 10,000. And again, that *Q option gave me what range these numbers are typically in. So this, I'm leaving them commented out, but this would help prevent a thread storm or a process fork storm on my system. And I would have to log out and log back in and have those uncommented for it to take effect. Does that make sense? Are we okay with that?
Mm-hmm.
But the way it is by default, 2 logins, and I can storm the system and make it unusable, and a reboot would be required. Okay, let me go back. So I was kind of on here, and then my page flipping stopped working. Now it's working. I got to do something, glue my USB cord in or something. So here I was using a *V. These are instantaneous numbers, not an average, but this is showing me how much directory entries I have, how many files are open, and how many inodes. And again, this stuff is in the slab. And there is a slab top -S-C that I use quite a bit to see when I have a large slab how big it is. Now let me save that for after break. Also *Q. Now again, Performance Copilot can get to this data as well, but run queue size is the number of processes running and runnable. So run queue is running and runnable procs or threads. The load average is running, runnable, but also data I/O weight, and also metadata I/O weight. Now this happened in Sysctl 11 that they started adding in data weight and metadata weight. So I could have an NFS server where the CPUs are idle, but I still have a huge load level, which are processes waiting on I/O. So if I'm waiting on something, what would I look at to see what a process is waiting on? What would be a good thing to look at?
You get the out in the PS, then you're on the W channel, whatever it is.
Exactly. Thank you, Mike. WCHAN. So if it is I/O wait, you will see things like get request, sync page, and they may be spelled different depending upon your kernel. Block congestion. You will see some things like a DIO for direct I/O. And you might also see an NFS_wait. So if I have a high load level, any one of these processes that is waiting on those type of events would show up in the load level. And in reality, it is a routine called IO_sched. Now, in older kernels, they used to print out just IO_sched, but now when they print WCHAN, they say if it's a generic lock, go to the subroutine and the stack trace above it. And that's when you're going to see get request, sync page, block congestion, things like that. You could also go into crash and look at the entire stack trace to see how it got to IO_sched. I hope to do that later in the week. The other thing for the load level now is metadata wait. And this is the down lock, not the IO_sched lock. And here I often see things like XFS_ or buff_, things of that sort. So WCHAN, when it's data I/O wait, we're going to see routines that are get request, sync page, block congestion, stuff like that. And the actual lock handler is IO_sched. For metadata wait, such as inodes and directories and stuff, you're going to see a down lock instead of IO_sched lock. And then there are a variety of routines that can be calling that. So NFS servers may have a lot of metadata activity and show up, and then when you're looking at WCHAN, you might be able to spot which processes are part of the load level. So this load level is a 1 minute, 5 minute, and 15-minute average, what's called a smoothed average or a rolling average. In other words, we're not responding instantaneously, but this is the average during the last minute. In fact, I can see here 15 minutes ago we had a small load level and we've bumped up to 2.3, so there is something going on that's increasing in this system. In fact, I can see at 13 here, which means that whatever happened has happened in the last 5 minutes, but not in the last 15, because this is slowly starting to grow. So this one will grow first, then this one, then this one. So looking at this, I can see, what has happened in the past minute. Actually, the last 5 minutes, really, that the load level has started growing. Are we okay with that? Any questions? So, your lab, I want you to play with Sysctl parameters. I need to resolve stability issues first. That's why I did that. I looked at var log messages and I changed that NMI panic on an unexpected NMI. And in lab, you're going to play with threads-max and also play with sar-qv. In lab, there will be this mystery script. Mystery 1 script, which basically forks a make proc process that sleeps for 60 seconds. So the fork is going to show up in the load level, but all these processes are sleeping for 60 seconds, so they will not show up in your load level. And again, this mystery script will be found in home, guest. You might want to copy it, sys_a_labs, advanced_labs, and then something like 01 underscore sysctl, something like that. Now, in my workbook, I added a new chapter in front of this called Connecting. I did not cover that module. We kind of did that in demo, but the numbering scheme for the tarball doesn't match the workbook numbering right now, I'm pretty sure. Any questions on that? I'd like to take another quick break here before I start the next module, give you a chance to clear your head and stuff. Let's come back at 1:30. And I know this is getting late for you, Mike, so hang in there with me.
Okay.
So let's come back at 1:30 in 15 minutes. And then we're going to do the VM, part of the VM module. Okay?
Okay.